Hi, my name is John Schilling, and I'm a chemist here at Pacific Northwest National Laboratory. And today I'm going to show you some of the research I do here in my laboratory in the Atmospheric Measurement Laboratory building. So at PNNL, our group tries to understand aerosols and clouds and the interaction between them. And the ultimate goal is to improve the representation of aerosols and clouds and these processes in global climate. So what we do is we take instrumentation out into the real world, usually through DOE's Atmospheric Radiation Measuring Program, the ARM program, and we make observations about aerosols and clouds, and then we form some kind of hypotheses about what is really happening, what are the key processes that are driving the formation of these particles and these clouds. But the real world is often very complicated. Sometimes the weather doesn't cooperate, sometimes the wind blows the wrong way, so it makes really validating these hypotheses challenging. So what we'd like is really a way to reproduce what's happening in the real world, but under very controlled conditions where we can hold everything very constant and change only one variable at a time. And that's what we do here in my laboratory. So specifically, what I do is I study the processes that convert gases into aerosol particles. And this is important for climate for two main reasons. The first reason is that aerosol particles in the atmosphere obscure the sunlight that reaches the surface from outer space. And you can see an example of this when mountains are hazy or city skylines are obscured on hazy days. This is because the particles are blocking the sunlight that's reaching your eyes. The second reason that this is important is that all clouds start as an aerosol particle. So if we didn't have these particles in the atmosphere, we wouldn't be able to form clouds. And if we had no clouds, we'd have no rain. And obviously the world would be a very different place. So what we're trying to understand is these particles, how they form, and the complex interaction that occurs between these particles and clouds. So it turns out in the atmosphere, from observations, we know that much of the aerosol mass is actually formed in the atmosphere from interactions of organic gases and things that are man-made. So what happens is plants and trees emit a lot of organic gases. An example of this is that characteristic pine smell in a pine forest. That's coming from gases that the pine trees are emitting. And then also, lots of gases come out of things like tailpipes and from factories and from other human-made activities. And in the atmosphere, these two things interact, and they interact with sunlight, and they transform the organic gases from the trees and the other plants into particles. And that's what we try to reproduce here. So what we do is we take gases that are representative of tree emissions. We also inject gases that are representative of anthropogenic emissions, and we then inject them into this chamber. They interact with this light. This purplish glow that you're seeing is from the lights that are meant to simulate sunlight. And this interaction with the light and with each other causes this complex series of chemical reactions, and it transforms the gases into particles. We then take the particles out of the chamber, we sample them with the same instrumentation that we use in the real world, and we try to draw our relationships between the properties of the particles and the chemistry and their ability to form clouds. We then take this knowledge and we put it into climate models, and we then try to understand how the particles influence things like clouds and rainfall rates. And one of the interesting things that we found in our laboratory is that depending on the number and the types of the particles and how they form, they really can have an impact on the clouds and even impact things like rainfall rates and change where the rain falls and how heavy it is. So this is just one example of how these seemingly kind of esoteric and complicated processes really affect everyday lives. So thank you for touring my laboratory here in the Atmospheric Measurement Laboratory.